Welcome back to the channel. So last time we were working on this flywheel and we're going to finish that up today, and the crankshaft. So the first thing we're going to do is go ahead and drill and tap this hole here for 540, and to hold this I'm going to use a 1/4 inch 5C collet in this collet block, so we can stick the crankshaft in here and tighten this up, and then we can line this up in the drill press and get it squared up so that'll hold the crankshaft. And then we know that we're going to drill this hole parallel to the crankshaft, so we'll use that and drill and tap that. And then we need to drill and tap for a 3/48 set screw in this flywheel. So I'm going to set this up in the drill press in the vise, and then we'll center it up, and then we're going to tilt the vise up. And it doesn't give an angle on this, but we'll run a drill bit down and just see what looks like a good angle, enough to where we have clearance here to the inside of the hub. And then about halfway in, so we're in the middle there, we're going to drill and tap that for the set screw. And then we're going to make the crank screw here, and this is a 1/4 inch hex, and I have some 1/4 inch hex stock, and this stuff is pretty cheap to make. If you're making a lot of screws or bolts, you can certainly make your own hex, but this hex stock works really good to make stuff like this. So it's already 1/4 inch hex, so we'll get that turned down here to the 3/16, and then turn it down 1/8 on the end, and then it gets threaded 540 to screw into the end of the crankshaft web. So we'll get these holes drilled and tapped, and then get this crank screw. This is just a simple turning and threading operation in the lathe. So we'll get this set up and get it made. We are going to machine this taper on the base and the sub base. The sub base has a taper all the way around it, and then the base has a taper all the way around it except here where the bearing goes. So both pieces are a 1/2 inch tall, and there's a 1/16 taper to it. So I did some math, and that comes out to 7.2 degrees, so roughly 7-degree taper. So to machine this long piece, since we're machining all this in the lathe, if we was doing it in the mill, it would be a lot easier, but to set it up in the lathe, I need to be able, if this is the cutter, I need to be able to angle this at 7 degrees to machine this long cut. So the setup that I have, I can't really angle my vise. So what I've come up with is, if you're looking at the end of the vise, what I'm going to do is I'm going to make 2 blocks that's got a 7 degree angle on them. And then we'll clamp the piece in here in between the blocks, and then the block on the bottom side have a 7 degree angle. So these 2 blocks, this will be block 1 and block 2, and then this will be our stock here. So then this, the vice jaws can still clamp against each other, because this side will be parallel to this side, but then it'll hold our stock at 7 degrees. So I cut 2 short pieces of aluminum here. I'm going to square up the ends, and then we're going to put these vertical in the vise, and then I have a 7 degree block that we'll set that in there, and we can set it in the vise at 7 degrees, and this will be the cutter here, and then we can machine this face. So I think this is 2 inches. I think I've got enough travel on my setup to machine the full 2 inches. So we'll machine this face at 7 degrees, do the same thing on this, then we can stack the 2 blocks on top of each other in the vise with our piece in the middle. And then we can clamp this down in the vise, have it sticking out, and then this will be angled at 7 degrees here on the end, and then we can take a long cut here and machine this taper on the end. This is all new. I've never done machining in the lathe like this, or doing milling using the lathe, so some of the setups kind of new to me. So we're going to try this and see if it works. So I'll get these pieces set up and get them squared off, and then get them machined, and then we'll see if it works. Okay, so that worked pretty good, holding these pieces and doing the tapered milling. Got the sides all milled. And then we didn't mill it here where the bearing block goes. Stay straight. So I was able to use these pieces that we milled and clamp the piece in between them, and then was able to hold it at an angle and then mill the long direction. And then I was able to turn it this way in the vise and stick it out on the end and do some side milling and do these ends here. So that worked really good. It's easy to make these because you can put them in the vise and set the angle and just mill that off, and then turn them over and hold the piece at whatever angle you milled on there. So the next thing we're going to work on is this eccentric that goes on the crankshaft here. I want to go ahead and get that on here so that this flywheel or this crankshaft can't move, because if it moves any, and it's really tight right here, so if it moves out any, it's going to hit here. So let's go ahead and we'll go ahead and make this eccentric, and then it goes on the back side here, and then there's a set screw that holds it to the crankshaft, and then that'll keep the crankshaft from being able to move any. So it's a 5/8 on the OD, so I've got just a scrap piece of 5/8 steel here that we'll start with, and then we'll lay it out, and there is a 50 thousandths offset here, and then this gets turned down to 7/16. So we'll mark a line and then mark another line at 50 thousandths over, and then we'll make a punch mark, and then we'll set this up in the 4-jaw chuck, and then locate it on our point, and then we'll turn this down to 7/16. And then before we do that, we're going to go ahead and we'll drill it and ream it thin, and then we'll drill it and tap it here for a 3/48 set screw. So we'll get this set up and start working on it. Okay, so I got the eccentric made and got it installed here. So you can see how it goes back and forth. So this will hook to the valve eventually up here in the steam chest. So now I can spin this and the crankshaft won't move and this nut won't hit here. So to set this up, usually what I'll do is actually lay out 2 punch marks, and I'll lay out the center line, and then I'll lay out a punch mark where the 50 thousandths offset is. But I went ahead and drilled, once I had it in the chuck, I went ahead on this 5/8 piece and drilled and reamed a 1/4 inch hole, and then afterwards realized that I don't have anywhere to punch my punch mark because I drilled out the hole. So I did this one a little bit different, and it actually worked pretty good. I think it was quicker than using, so on that punch mark, which if you've watched my video on building the PM Research steam engine, I did it that way on the eccentric. Then on the punch mark, you can put a dead center in your tailstock, and then another dead center between that dead center and your punch mark, and then put a dial indicator on the dead center and dial it in. I'll show you that method when we get to the cylinder. We'll do it that way. So what I did on this one is put it in the 4-jaw chuck, and then I dialed it in to where it was 0 all the way around, so it was perfectly centered. Then I lined up 2 of the chuck jaws completely horizontal from each other, and then with the dial indicator I loosened this jaw, and then I just moved it over 50 thousandths, and then tightened this jaw against it so it was centered, and then we just shifted it over the 50 thousandths offset that we need, and then turned it down this to 7/16. That actually worked pretty good. Like I say, I think it might have been quicker than setting up the dead centers. I'm not sure, but both methods work. So while I have the 4-jaw chuck mounted on the lathe, we're going to go ahead and start working a little bit on the cylinder. We're not going to do the whole thing, but I am going to, it gets a 1/2 inch hole here. This piece is 1 inch by 1 inch, but then this hole is offset, so 15-30 seconds up and 15-30 seconds from this corner. We're going to put a 1/2 inch hole all the way through the cylinder. And then so I've got my piece here, which is 1 inch by 1 inch, and then it is a little bit long. We will turn that down eventually, but I've got a punch mark here at 15-30 seconds and 15-30 seconds from this corner. And I marked my corner here just in case we need to know which corner that we're starting from as our 0, 0. So I'll get this over in the 4-jaw chuck, and then we'll put a dead center in this hole here, and then another dead center in our tailstock. So as this piece moves, the dead center can wobble. Then we'll put our dial indicator against it, and then we'll dial that into 0. And then we'll be perfectly centered up on this hole. And then this hole does need to be smooth, because this is what the piston will actually be running into. So I will start drilling it, but eventually we will take a boring bar and do the final cuts on it. And then we might do some honing or lapping depending on what kind of surface finish I can get. But we'll get this on the 4-jaw chuck, get it dialed in, and get the hole in the middle of it. And then I'm doing it this way because there's other features here that get machined that's concentric to this 1/2 inch hole in the center. We can mount it on an arbor then, and just put it in a normal either 3-jaw or collet chuck, and we can hold it on that arbor, and then we can turn these ends, which get turned down round. So we'll get this set up and get the hole in the middle of it. Okay, so we got that cylinder bored. You saw me use the 2 dead centers on the tailstock to set it up and center it. And then took my time and snuck up on it and got a pretty good finish. In there. So I used a small hole gauge, usually for hole sizes under a 1/2 inch, and they come in a set. These work really good to measure the holes. This goes up to 1/2 inch for measuring small holes. These work really good. And then I checked it a few times with a gauge pen, and this is a 1/2 inch gauge pen. So if I put my finger on here, check the fit, you can see it's real slow going down. And then if I take my finger off the suction, so it's a good tight fit for a 1/2 inch. So we can now mount this on an arbor, on an expanding arbor, and then we can turn these ends round and we'll continue working on that, and we'll finish that up at a later date. So that's going to do it for this episode. Come back next time and we're going to start on the actual crosshead piece that rides in here. So we'll get started on it next time. Thanks for watching.